Another method used to solve quadratic equations is called completing the square. So say I gave you the quadratic equation x squared plus 6x minus 3 is equal to 0. So I encourage you to have a go at factorising this, maybe trying to solve that. And if you have had a go, you will notice that this can't be factorised. So how do we go about solving it? Well, we could put it into the quadratic formula, or we could complete the square. So let's have a look at how we do that. I'm going to start with a simpler expression. Let's do this in a different colour over here. Let's start with x squared plus 8x. So we want that in the form of a square number. So a square number minus a constant. Well, I'm going to write down what I think should be in the brackets. I'll show you that. So what I would put in the brackets is x plus 4. So if I expand this bracket out here, I should get a quadratic expression. And it's not going to be quite the same as what I would like, this top line here. I encourage you to have a go at doing this yourself. But we will get x squared plus 4x plus 4x plus 16. And if we simplify that, we see that there's an extra plus 16 here. And at the end of this quadratic expression, there isn't a constant. So if we subtract, so this line here is equal to x plus 4 squared, expanded out. And if we subtract 16 from both sides, we can see that now we have on the right-hand side the exact same expression as we wanted. So here, on the left-hand side, I have a square, and I'm taking away a constant from it. So this here is the correct form I need when completing the square. So just like up here, where I have a bracket squared, and I'm taking away a constant, I have the exact same form down here. So I started off doing this by writing down a bracket squared. I knew what that bracket was going to be. And how did I know that? Well, this plus 8 is going to be formed by two x terms added together. And you can see that each of these x terms is half of the total x term that I want at the end. So the number that needs to go inside the bracket is simply half of the number in front of the x term. So let's have a go at completing the square for this expression on the left. So first of all, I need to find my brackets. And so I take x, as this x is what gets my x squared. And then, like before, I'm going to need half of the integer in front of my x term. So I'm going to add 3. And in order to find out what the number subtracted or added at the end needs to be, so here I needed to subtract 16 in order to get my original expression. Let me expand these brackets out and see what we end up with. So here I have plus 9 at the end, except I would like minus 3. So in order to get from plus 9 to minus 3, I need to subtract an extra 12. Now this here should simplify to get me to my original quadratic equation. And so I've completed the square for this original expression. I now have a bracket squared, and I am taking away an integer from it. And we set that equal to 0. And that is my same quadratic equation written in a different form. So why are we doing this? Why does this help us? Well, if I rewrite this underneath, I can now solve this without the need of factorizing. So if I add 12 to both sides, and what can I do to both sides of this equation now? Well, I'm squaring the left, so let's square root both sides. Remembering that when we square root a number, we can find the positive and the negative root of it. So this becomes root 12. And we can simplify this root 12 even further. We can say that it is equal to plus or minus 2 root 3. And now I have plus 3 on the left, so let's subtract 3. And the common notation is we put the number without a root in front, so we've got minus 3 plus or minus 2 root 3. So using this method, I've worked out the two solutions, because this could be positive or negative. I've worked out the two solutions for my quadratic equation by completing the square. So hopefully you can see how I got from my original quadratic equation. I've completed the square, and then using that, I have been able to find the two solutions for x. So let's have another go at a question as an example. So I have x squared plus 12x minus 5 is equal to 0. And if you try factorizing this, you'll see that it's not possible, so we have to complete the square. First, let's figure out what goes inside our brackets. Obviously, we need an x at the front in order to get our x squared term. Then I take half of the integer in front of the x, which would be plus 6. Let's expand that out in order to balance the final number. So we see that the integer at the end is plus 36, and we want minus 5. So we are going to have to subtract 41. And if we now simplify our expanded expression, we will see that x squared plus 12x minus 5 is equal to this form of the completed square. So now let's take the completed square form and set that equal to 0. We can add 41 to both sides. And then take the square root, remembering that it can be positive or negative. So we've got plus or minus the square root of 41. Then we can subtract 6 from both sides. So minus 6 plus or minus, this is the notation we use, of the square root of 41. So that's our second example of solving a quadratic equation by completing the square.